Hey, good morning. Good morning, students. I am Dr. Deep Chemanikam from Department of Competition Intelligence, Saram Institute of Science and Technology. Today's session, we are going to discuss about the queue data structure. So, data structure is very important for developing an applications, various applications application. So here, queue, with the help of this queue, we have to implement the various development in terms of designing an architecture or developing an applications. And the queue is one of the important data structures that models enforces the first come first serve are equivalently in the first come first order. That is before normally if you are using the queue for getting the tickets or that is first order. We have to follow that. Another one more thing is that this is a way for representing the queues. Next one thing is the operations of the queue. So what do you mean operations of queue? Here we are using the two important operations. One is that push, another one more is pop operation. The push operation, what is the use of this? Now we need to insert an element into the stack or into the queue. Our next one is pop. So pop operation is equivalent to the DQ. So we can delete an element from the given queue item. Okay, so these two things are mainly, these two operations are mainly used to implement the operations of queue. For example, I'm just here we just follow the first come first order. First come first in first order. Here we just consider the first node as an A. So here first we just insert an element as push. So after this, that is we are using the two different pointers. One is front and rear. I will explain that. So the front pointer that should represent at the initial level, and back means we just inserted back. So I will explain detail in the further slide. So the first one thing is the queue operation. If we want to perform the two different operations, that is called as an push and pop, with the help of this the two different pointers. One is a front pointer, another one is a rear pointer. So these two pointers are mainly used to support this the queue operations. What are all the additional operations on the queues? One is an insert, next one is a remove, and third one is a get head and get tail and is empty and size. So what about the insert? Insert means we just insert an element into the queue. That is also called as an NQ process. And DQ process is a remove process, also called as an delete or DQ process. So it deletes an element whatever the front pointer points on the queue. And the third one is an get head. So what is the meaning of this in the get head? That is, it should return the value of the head element of the queue and the get tail. So what about the get tail means return the value in the tail element of the queue. Another one more thing is ECMT. So what about the ECMT means? So it returns true. There is whether the queue is empty or full. Suppose if the empty means we just able to easily insert an element into the stack. Suppose if the queue is empty, it is very difficult to delete an element. We are not possible. So for these aspects only uh, we need to represent, or we need to uh, uh, that is verify the status of the CMP, and is full also, and size. So what about the size means? That is written the number of items in the queues. Okay, and suppose if we are creating the queue consists of the three different pointers. One is an count is equal to 0, and the front is equal to -1, and the rear is equal to -1. So we are so this is a way for initializing the variables for creating the queues. Another one more thing is how we are going to perform the MQ operation. So how we are going to insert an value only into the queue. So how we are going to insert an element into the queue. So first one thing is, first step, we just check whether the queue is full or not. So how we are going to check? Already we are using the one pointer is called as a rear pointer. So rear equal to the size minus 1. So check whether the queue is full or not. Second one thing is, if it is full, we just print the statement as full, or insertion is not possible. Suppose if the queue is not full, then to increment the rear value by 1, that is rear plus plus, and set q of rear is equal to value. Okay, so these three steps that should be followed for inserting an element into the queue. This is a one best example for representing an array. So how we are going to represent the operations in an array. So earliest implementation, and that keeps all the track of number of items into the stack and the index of the first element. Okay, for example, here we are maintaining three different values. One is size, another one more is first, another one more is last. So here we just see this is the initial setup of this the queue. So one thing is the 4 is stored in the first location, and 8 is stored in the location 1, and 6 is stored in the location 2. Okay, so size means number of size is equal to 3, and the first indicates as value is 4, and last indicates the value is 2 here. No, okay, so this is an array implementation, and we don't worry about that. We don't care about what is the remaining part. So we don't worry about that. So, so how we are going to insert an element? Suppose the initial step, what we are going to do this. So we need to check whether the queue is full or empty. If it is full, we just store all the elements. If it is full means no problem. So there may be a possibility to insert an element into the stack. Suppose if the stack is empty, means we are not able to. If full means we are not able to insert an element. So we need to check whether the stack is full or empty. It is not full means we are able to easily insert an element into the stack. Suppose if it is full, means it is very difficult to insert. Insertion is not possible. So this is the way we are going to do. Suppose for considering this example, again I want to insert one new element as 2. So 2 means there is the insertion is possible at the end of the queue only, not in the front. So end of the queue only we are doing this. So 0862. We just increment, we just check whether the queue is full or not. The queue is not full. There is some space is there. Okay, no problem. So after that, we may able to do that, or we may able to retrieve this or retrieve the next position of the location and store all those information. So this is the way we are going to insert an element in this queue. Another one more thing is this is a pseudocode. So you need to check the rear is equal to size minus 1. If the condition is true, the queue is full, the insertion is not possible. Suppose else part means, so if front equal to minus 1, so front is equal to 0 and rear plus plus. So q of rear is equal to value. So the value is stored in the queue of rear, and the insertion is successful. So this is a pseudocode for representing the insertion operation. So what about the dequeue operation? Dequeue operation is and the deletion of deleting the value from the given queue. First we need to check whether the queue is empty. So front is equal to rear. So if both the values are same, so the queue is empty. So next one thing is, if it is empty, then the queue is empty. So the reduction or deletion is not possible. Okay, and step 3 is, if it is not empty means, so what we are going to do is the front can be incremented by front plus plus, and we need to point out the corresponding position of the queue. There is queue of front can be deleted, and we need to move it further by one step. So this is why we are deleting an element from the queue. Now, for example, consider this one. So when this is an array size, so initially we are having the size is 3, and the front represents a 0, and the last position represents the second position. Suppose if we are deleting an element, deletion is possible at the front only. Then there is in the front point, that should be incremented by 1. So we need to update the corresponding position of the given variable. So 2, 1, 2. And the reason here total number of size of the element is 2. The first value is 1, and second value is 2. Another queue deletion. So how we are going to delete an element. So the DQ is an operation. So in the deletion process, this is represents the deletion process. So we need to check if the front is equal to the rear. So queue is empty, so it is very difficult to deletion an element. So next one thing is else part. So what about the else part? So the deleted, that is here we need to increment the pointer. That is deleted, that is queue of friend and friend queue friend plus plus. So friend plus plus means we need to increment the friend value by 1. So if friend equal to rear means, so we need to check it as friend is equal to rear is equal to -1. So this is the way we are going to delete an operation. So next one thing is the display of elements. So we need to check the queue is empty or not. So empty means what is the condition? Front is equal to rear. If it is empty means queue is empty. Suppose if it is not empty means some more elements are available in the queue. So we need to read all those elements from the queue and displayed in the screen. Whenever the condition is until the condition is false. That's all. Okay, thank you for your